welcome back to my channel. Today we will continue discuss on Pre-Pspm questions set 5. So you can click on the link below to answer the Pre-Pspm questions. So let us start with questions number 1. The symbol of the dimension of the mass, length and the time is m, l and t. What is the dimension of the impulse? So we know that impulse is equal to change of the momentum, or we can write as nv minus mu. Okay, so the dimension for impulse is actually nv. So m is the dimension for the mass is capital M, v is lt negative 1. So the answer is A. Questions number 2. The motion of the object in a straight line is shown in a graph. Find the velocity from t equals to 8 seconds until t equals to 10 seconds, meaning that we want to find the velocity from C to D. Okay, so this is the graph displacement versus t, where the velocity we can use ds over dt or the gradient. Okay, so we can take point C and point D, the gradient for point C to point D. Okay, 40 minus 0 over 8 minus 10. Therefore, 40 over negative 2, and we will get negative 20 meter per second. So the answer is B. Okay, questions number 3. A train is moving with the velocity 25 meter per second. It brakes with the deceleration of 2 meter per second square before it stops. Find the time taken for the train to stop. Okay, so what are the informations we have? We have the initial velocity 25 meter per second, and it already mentioned the deceleration, meaning that A is equal to negative 2, and finally it stops. So meaning that the final velocity is equal to 0. So we want to find the time taken. Okay, so equation V equals to U plus AT, we can determine the time taken. Okay, so we substitute V equals to 0, U is 25, plus A is negative 2T. Okay, so finally the answer for the time taken is equal to 12.5 seconds. Answer is B. Questions number 4. A cannonball is fired at an angle of 30 degrees to the horizontal with a speed of 100 cm per second. Calculate the horizontal range after 5 seconds. Okay, so meaning that we want to find the value for x-axis, and we know that x-axis is equal to uxt. Okay, so this is the diagram where it shoot up with the angle of 30 degrees. Okay, so we want to find what is the value for x-axis. Okay, after 5 seconds. Okay, so we can find it by using sx equals to uxt, where ux is equal to 100 cm. Okay, so we need to convert it into meter per second. So we times exponent negative 2 cos 30 degrees. And the time taken at that time is 5 seconds. Okay, so after pressing the calculator, therefore, the horizontal range of the projectile after 5 seconds is 4.33 meter. Answer is D. Okay, next we want to find, next question number 5. Determine the final velocity of ball B if two balls A and B each with the velocity 25 cm per second and 15 cm per second are moving in opposite direction. The two balls collide with each other and bounce off. So the mass of ball A is 20 grams and for ball B is 25 grams. Okay, so we want to find what is the final velocity for ball B. Okay, so for this case, it's actually conservation of momentum, where we can use we can resolve it into x and y component. Okay, so the first one is conservation of momentum for x component. Okay, where we can write m1 u1x plus m2 u2x equals to m1 v1x plus m1 m2 v2x. Okay, so initially u is given 20 grams. Okay, so it's 0.02 times the initial velocity is 25. Okay, so it's still in cm, and we can change it into meter per second, plus m2 is 0.025, and the initial velocity, because it's moving to the left, so we must substitute negative 15 exponent negative 2, and the final after the collision is 0.02 is moving. Okay, if we resolve, it's moving to the left, so we must substitute negative 10 exponent negative 2 cos 35 plus 0.025 times VB for x component. Therefore, VB for x component, we will get VBx, we will get 0.1155 meter per second. Next, we'll go to y-axis. For y-axis, initially, ball A and ball B are moving left or right. Okay, so meaning they only involve x component. So initially, there is no y component involved. And after the collision, ball A is moving upward. Okay, so this is your V1 y component. Okay, so we can write at 0.02 positive 10 exponent negative 2 sine 35 degree plus 0.025 VB for y component. Okay, so we will get VB for y component. The answer is 0.0459 meter per second. Okay, and the answer is actually negative because it's moving downward. Okay, so finally, V resultant is equal to VBX square plus VBY square. Okay, so the answer that we will get is 0.124 meter per second. Okay, so the answer is, the nearest one is A. Okay, next, questions number 6. A bullet with 10 grams shoot the stationary block 1.99 kg with the velocity 300 meter per second. After the collision, the bullet is embedded inside the block and moved together with the velocity 1.5 meter per second. So determine the impulse of the bullet. Okay, so impulse equations is actually equals to change of the momentum, where we can write it as mv minus mu. So since the question asks us to find impulse for bullet, so we can substitute mass of the bullet is 0.01, and the v is the velocity, the final velocity, where it's moving with 1.5, and the initial velocity is equals to 300, so it's minus 300. Therefore, we can get the answer of the impulse is equals to negative 2.985 kilogram per second. Okay, so the answer here is A. Next, questions number 7. Two blocks A with the mass 10 kg, B with the mass 30 kg are side by side and in contact with each other, moving with acceleration 5 meter per second square. They are pushed along a smooth floor under the action of constant force, and the magnitude is 200 applied to A as shown. Determine the force exerted by A on B. Okay, so here we have F external, where the question mentioned that the F external is 200 Newton. Okay, so they ask us to find the force exerted, exerted by A on B. Okay, so we want to find by A on B. So this is the reaction force by A on B. Okay, so here actually we have another force where it's from B acting on A. Okay, so from the Newton's third law, we know that when there is an action, there will be a reaction. Okay, so actually RAB is equal to RBA. Okay, I mean the magnitude for both of them actually are the same. Okay, so what is the difference here is actually the direction. Okay, the direction, one is positive, meaning that it's to the right, and another one is negative, meaning that it's moving to the left. Okay, so we can use F resultant on point on A is equal to MA. Okay, so the motion is actually accelerate to the right, because the force is acting to the right with 200 Newton and it's accelerate with 5 meter per second. So the acceleration here is 5 meter per second square. Okay, so for object A, okay, the free body diagram here is normal force, we have mg, okay, we have the reaction force B on A, and also we have the F external 200. Okay, and the motion is moving to the right. So Fx equals to MA, where for A 200 minus RBA is equals to MA, where M for A is 10 kg. Here is 10 kg. So we substitute 10 kg and acceleration just now is 5. Therefore, RBA is equals to 200 minus 50. And the answer we will get is 150 Newton. Okay, so this is the reaction force B on A. Okay, if let's say you want to use B to find, we also can use B to find, where for B, we have normal force, we have mg, and at the same time, it experiences the reaction force A acting on B. Okay, so Fx for object B is equal to MA, where for X component, for object B only, the reaction force A acting on B. So we can write RA acting on B is equal to MA. Okay, where M for object B just now is equals to 30 kg. Okay, so we substitute 30 kg times the acceleration phi. Therefore, we will get 150 Newton. Okay, so the answer is actually similar for RBA or RAB. Okay, so the answer here is actually equals to D. Okay, next. Question number 8. The object is moving with constant velocity, meaning that the acceleration is equals to 0 with the coefficients of the kinetic frictional force 0.2, meaning that here we have mu. Okay, find the normal force acting on this object. Okay, so this is actually chapter 4. Before we find the normal force, we need to draw the free body diagram first. Okay, so since 20 is actually greater than 4, meaning that the motion is actually will move to the right. So when the motion is moving to the right with a constant velocity or A equals to 0, meaning that the frictional force will move in opposite direction. Okay, and also we have normal force and also mg. Okay, so these are the forces involved. So when we want to find normal force, we know that normal force is actually equals to mg. The problem here is we don't have the value for the mass. So we can use frictional force equals to mu n. Okay, to find the normal force. Okay, so but before that, we need to find what is the value for frictional force first. Okay, so I will sketch the free body diagram. Here we have 20, we have 4, and also we have friction. Here we have normal and also mg. Okay, and the motion is moving to the right. So fx equals to ma, where 20 minus 4 minus friction is equals to ma, where a, because we constant, so a is equals to 0. So finally, the frictional force is equals to 20 minus 4 or is equals to 16 Newton. Okay, so we can substitute into the equation just now here. Okay, where the frictional force equals to mu n, so it's 16 equals to mu, where from the questions given mu is 0.2. Okay, so we substitute 0.2 n. So the final answer for the normal force, we will get 16 over 0.2 or is equals to 80 Newton. So the answer here is A. Question number 9. A 3 kg box is lifted vertically from the rest to the distance of 2 meters with the constant upward applied force 60 Newton. Determine the total work done by the system. Okay, so here we have F applied or F external equals to 60 Newton, and the block is actually experienced mg, which is acting downward. Okay, so since the questions already mentioned is moving upward with the distance of 2 meters, so they ask us to find the total work done. Okay, so the total work done is equals to F total times the displacement cos theta. Okay, so we need to find what is the value for F total, okay, or F net. So from this question, F net is only involve y component, so it's Fy equals to ma. Okay, so for y component, F external is F external minus mg is equals to F total, where F external here is equals to 60 Newton and the mass here is 3 kg, so it's 3 times 9.81. Okay, so the F total actually we can get 30.57 Newton. Okay, so we substitute into the equation where F total, which means Fy is equals to 30.57 and the displacement is 2 meters. Okay, cos theta, where the angle is actually equals to 0 because F net is moving upward and our displacement also is moving upward, so it's cos 0 degree. So finally, the work total we will get is equals to 61.14 joule. Okay, so the answer is A. Question number 10. A 0.02 kg sphere slide down a smooth and curvy surface. The sphere is initially at rest. Use the conservations of energy to calculate the velocity of the sphere as it passes at point B. So we want to find what is the velocity when it reaches point B. Okay, and the question mentioned initially our V at point A is equals to 0. Okay, so we can use conservations of energy where total energy at point A must equals to the total energy at point B. Okay, so since this is a smooth surface, meaning that there's no work done to overcome the friction. Okay, so we only need to consider kinetic energy initial plus potential energy initial equals to K final plus U final. Okay, so initial, because V is 0, so there's no kinetic energy. And potential energy is actually mgh. M is 0.02, G is 9.81, and at the moment, at point A is equals to 20 meter. And it's equals to K final, where K final is equals to half M 0.02 V squared plus mgh. M is 0.02 times 9.81, and at that moment, at point B is equals to 10 meter. Okay, so actually 0.02, 0.02, 0.02, we can cancel off. Therefore, the final velocity at point B is equals to 14 meter per second. Okay, so the answer is D. Next question, number 11. The stationary car with the mass 1500 kg moved with a velocity of 10 meter per second in 5 minutes. So the answer is to find the power. Okay, so as we know, power is equals to the rate of work done. Okay, where here work done, because it's moving with the kinetic energy. Okay, so we can use change of the kinetic energy over time taken. Okay, so we can use half mv squared minus half mu squared over t. Okay, where half m is 1500, v is equals to 10 meter per second. And then initially u is equals 0 because the question mentioned is stationary. Okay, so it's minus 0 squared. And the time taken here is after 5 minutes. So 5 minutes we must convert it into second. So times 60 seconds. Okay, so the final answer for the power is actually equals to 250 watt. So the answer here is D. Okay, questions number 12 is actually chapter 6. Okay, here we have a conical pendulum with the mass 100 gram and the length is 0.5 meter, making the angle of 70 degree to the horizontal, meaning here is 70 degree. Okay, so determine the speed of the pendulum. Okay, so here we actually know that this is questions related to centripetal force. So we can first draw the free body diagram first, where we have the tension and also mg is acting downward. Okay, so this is the free body diagram, where here we have mg and tension is at the angle of 70 degree. Okay, so since the motion is moving horizontal, meaning that here we have our F, centripetal force is acting to the right. Okay, so if we draw free body diagram, we will get mg is acting downward, tension is 70 degree to the horizontal, and fc is to the left. Okay, so here we can construct two equations. The first equation is fx equals to ma, where fx here is tension cos 70 degree is actually equals to our centripetal force mv squared over r. So this is our first equation. And the second equation is Fy equals to Ma. Okay, so since the pendulum is only moving in horizontal, meaning that Y component is equals to 0. Okay, so we can write T sine 70 degree is actually equals to Mg. So this is the second equation. Okay, so we can write equation 2 over equation 1, where T sine 70 over T cos 70 degree is equals to mg over nv squared over r. Tension and tension we can cancel, m and m we can cancel. So finally, tangent 70 degree is equals to rg over v squared. Okay, so since we want to find v, so the equation here is v is equals to square root rg over tangent 70 degree. Okay, so r here, okay, usually student will take r equals to 0.5. Actually 0.5 is not the r, 0.5 is the length of the string. Okay, so r here we must take the radius of the centripetal force, where r here is actually equals to, okay, so we can find the value for r. Okay, so here is 0.5, so actually r here is equals to 0.5 cos 70 degree. So 0.5 cos 70 degree, we will get 0.171 meter. Okay, so we substitute into the equation. R is 0.171, G is 9.81 over tangent 70 degree. Okay, so finally the velocity that we will get for this conical pendulum is equals to 0.781 meter per second. So the answer here is B. Question number 13 is chapter 7, where the Earth of the mass is 6 exponent 24 and the radius is 6.4 exponent 6 meter. Determine the gravitational potential energy of 1000 kg communication satellite orbiting the Earth at the altitude of 40,000 km from the Earth. So we want to find the gravitational potential energy. Okay, so here this is the satellite where the satellite is at the altitude h. Okay, 40,000 km. So it's actually 4 exponent 7 meter. And remember, the radius is actually we must take from the center of the planet. So later we must plus the radius of the Earth. Okay, so the potential energy equation is equal to negative Gm over R, where G is 6.67 exponent negative 11, and the mass of the Earth is equal to 6 exponent 24, and the mass of the satellite is 1000 kg, so it's 1000 over radius. Okay, so as mentioned just now, the radius you must take from the center, so we must take the radius of the Earth plus the altitude. Okay, so the radius of the Earth is 6.4 exponent 6 plus the altitude is 4 exponent 7. Okay, so remember to substitute negative. So finally, we will get negative 86.25 exponent positive 8 joule. Okay, so the answer here is C. Next, question number 14, still chapter 7. Determine the gravitational field strength at the surface of the Earth. So, the gravitational field strength Ag is equal to Gm over R squared, where G is 6.67 exponent 11, and the mass of the Earth is exponent 24. Okay, and the radius here, because it's at the surface, meaning that the radius here is actually equal to the radius of the Earth. 6.4 exponent 6, and remember to square. Okay, so finally, the answer that we will get is equals to 9.77 meter per second square. Okay, so the nearest answer is B. Okay, next, question number 15 actually is chapter 9. So the displacement of the particle oscillating in a simple harmonic motion, so they give you the equation x equals to 4 sine 10 pi t, where x is in cm and t is in second. So determine the velocity of the particle when x equals to 3 cm. Okay, so here they give you x, okay, equals to 3 cm. So we want to find the velocity, we must use this equation where v is equals to omega square root a square minus x square. Okay, where omega here is actually 10 pi and the amplitude is actually 4, but still in cm. So I substitute 4 in cm minus 3 also in cm. So the answer that we will get is actually 83.12 cm per second. Okay, so we need to convert it into meter, where after converting it will become 0.83 meter per second. So the answer here is A. Question number 16. One end of the tuning fork oscillating in simple harmonic motion with the amplitude of 0.5 millimeter and the period is given 0.001 second. Deduce an expression of the displacement in meter in terms of t in second. Okay, assuming that when t equals to 0, the end is at the equilibrium position. Okay, so this actually shows us that when t equals to 0, x also start from 0. Okay, so meaning that this is actually a sine graph. So the equation x will equal to a sine omega t. So this is the general equations for the progressive wave. Okay, so this is a general equation for the simple harmonic, where a here they give you 5 millimeter. Okay, 0.5 we must times exponent negative 3, convert it into meter, sine omega t, where omega is equal to 2 pi over t, and they give you t is equal to 0.001 and times t. So finally, we will get x is equal to 0.5 exponent negative 3 sine 2000 pi t. Okay, so the answer here is equals to D. Question number 17. The displacement of the particle with a mass 0.5 kg oscillating in simple harmonic motion, and they give you x in meter equals to 4 sine 10 pi t. Determine the kinetic energy when the particle at the amplitude. Okay, so when the kinetic at amplitude, actually we know that the kinetic energy is actually equals to 0 joule. Okay, so actually from the equation of kinetic energy, K equals to half m omega square a square minus x square. Okay, so if we substitute half m omega square equals to times a square minus x square, where a is the amplitude, and because the question asks us what is the kinetic energy when it is an amplitude, so it's a square minus a square, therefore we will get 0 joule. Okay, so actually you don't need to calculate, you will know that if let's say the kinetic energy at the amplitude is actually directly, we will get 0 joule. Okay, so next we'll go to questions number 18. The velocity of time graph of the particle in a simple harmonic motion is shown. So this is the velocity versus time. Okay, which of the following graph of the accelerations against time? So from the graph here, we know that the velocity is equal to a sine omega t, because this is actually show you the sine graph. So in order to get the acceleration is actually we need to differentiate vd over dt, where after differentiate we will get a omega, you differentiate sine, we will get cos omega t. Okay, so this is actually we will get a cos graph. Okay, so we find which one is a cos graph. Okay, so the answer is actually C, because C show you the cos graph. Okay, so this is a cos graph. Okay, next we'll go to questions number 19. What is the wavelength of the wave in the diagram? Okay, so wavelength here is actually from the crease to crease, where the answer here is 0.08 meter. Okay, so the answer here is A. Questions number 20. This is the standing wave. So this standing wave actually shows how many harmonic. Okay, so for the string, the first harmonic is actually equals to lambda over 2. Okay, here we have how many lambda over 2? We have 1, 2, 3, 4, 5, 6. Okay, so we have 6 lambda over 2, meaning that this is actually 6 harmonic. Question number 21. A sound wave source S produces sound in all directions. It's shown in the figure below. Let A be an imaginary spherical surface at a distance of r from the S, and P is the power of the source of the sound produced at S. Okay, what is the intensity of the sound at the spherical surface? So we know that the intensity is actually equal to power over area. Okay, so we can find which is the suitable equations. Okay, so from here, power over area, because this is a spherical, so the area for the spherical is equal to pi r squared. Okay, so the answer, therefore the answer here is actually this one, power over area. So the answer is D. Questions number 22. Determine the positions of the knot of the resulting standing wave of these two waves. So here we have two waves. The first one is 0.02 sine 40t minus x, and the second one is 0.02 sine 40t plus x. So we know that after these two waves form, it will form after these two waves combine, it will form a standing wave. Okay, where the equation of the standing wave is equal to 2a cos kx sine omega t. So this is a general equation of the standing wave. So we substitute 2a where a is 0.02, cos kx, here kx is only x, sine omega t, here omega t is 40t. Okay, so this is the equation after these two waves combine, where y is equal to 0.04 cos x sine 40t. Okay, so now we want to find what is the positions of the knot. Okay, so knot here is actually meaning that the amplitude of the particle is actually equal to 0. Okay, so 0.04 cos kx is equal to 0, meaning that cos kx will also equal to 0. Therefore, kx is equal to cos 0. Okay, where k here, because here is equal to 1, so it's x equals to pi over 2, 3 pi over 2, 5 pi over 2, and so on. Okay, so the answer here is A. Questions number 23 is actually Doppler effect, where the siren of the ambulance at rest emit the predominant frequency of 1500 Hz. Okay, what is the frequency will you hear if you are at rest and the ambulance is moved 26 meter per second towards you. Okay, so meaning that initially you are at rest, so meaning that your V is equals to 0, observer, and the ambulance is actually approaching you with the velocity of 26 meter per second. Okay, so this is an ambulance. So the Doppler effect frequency is equals to V plus 0, V because it's approaching, so it's equals to times the frequency of the shot. So we substitute V of the shot 330 over 330, and the shot is actually 1,500. Therefore, the apparent frequency or the frequency here by the observer is equals to 1628.3 Hertz. Okay, so meaning that you will heard a louder sound. And the answer is D. Questions number 24. Calculate the work done to extend the wire by 1.5 millimeter. So here they give you force versus elongation. Okay, so work is actually area under graph. So we need to find the area under graph for FE. Yeah? So this is the area under graph where work done is equal to half FE. So we substitute F is 300 and the elongation is actually 1.5 millimeter. So we need to times exponent negative 3. Therefore, the work done is actually equal to 0.225 joule. Okay, so the answer here is A. Questions 25. Two metallic rods X and Y with similar length and similar cross-sectional area are joined together and isolated at steady state. So the question say at steady state, meaning that dq over dt for X is actually equals to dq over dt for Y, because steady state meaning that the rate of heat transfer actually are similar. Okay, so the temperature of the rod X and Y are 100 degrees Celsius and 40 degrees Celsius respectively at each end. Okay, so here is 100 and the other end is 40 degrees Celsius. So the thermal conductivity of X is actually twice the thermal conductivity of Y. Okay, so here they give you the informations where K for X is actually twice of thermal conductivity for Y. So calculate the temperature at the junction between X and Y. So we want to find what is the temperature, okay, at the junction between rod X and also rod Y. Okay, so since the question mentions steady state, meaning that the dq over dt for X is equals to dq over dt for Y, the rate of heat transfer for both actually same because it's also isolated. So we substitute negative Ka dt over dx for rod X is actually equals to Ka dt over dx for rod Y. Okay, so since the question mentioned that area and also the length are similar, so we can cancel. And also we can cancel off the negative. Okay, so Kx is actually equals to 2 Ky, and the temperature for X is actually from here until here. So we will take final minus initial. So final here is T minus initial 100 degrees Celsius equals to Ky, and for rod Y is actually from T to 40 degrees Celsius. So we must take final minus initial, where final here is 40 minus initial T. Okay, so Ky we can cancel. So finally, 2T minus 200 is equals to 40 minus T, and the T is equals to 80 degrees Celsius. The answer is B. Next question is number 26. A 100 cm rod expanded by 8 mm when heated from 0 degree to 100 degrees Celsius. Calculate the coefficients of linear expansion for rod A. Okay, so here we have the original length 1 meter and the elongation is equal to 8 exponent negative 3, and the temperature changes is actually 0 to 100. Okay, so they ask us to find the coefficients of linear expansion. So we can use for questions number 26, we can use change of the length is equals to L0 times the linear expansion times the change of the temperature, where delta L is actually the elongation, 8 exponent negative 3, L0 is 1, alpha we don't know, and the temperature we must take final minus initial, where final is 100, initial is 0. Therefore, alpha we will get 8 exponent negative 5 per degree Celsius. So the answer here is B. Questions number 27. the molar mass of the oxygen is 32 gram per mole. Calculate the root mean square of the oxygen at the angle at a temperature of 30 degrees Celsius. Okay, so VRMS, we actually have two equations where it's equals to 3 kT over mass or 3 RT over molar mass. So since here they give you molar mass, so we will use the second equations to find the VRMS. So we substitute 3R is 8.31. Temperature, we must convert it into Kelvin. So it's 30 plus 273.15. And the molar mass is 32 grams. So we need to convert it into kg. Okay, so remember to convert it into kg. So the final answer for the VRMS is equals to 485.8 meter per second. So the nearest answer is actually C. Question number 28. A tank has the volume of 0.7 meter cube and contains of 2.5 mole of helium gas at the temperature of 10 degrees Celsius. If the helium behaves like an ideal gas, determine the total translational kinetic energy. Okay, so when you look at this word translational, meaning that only involve linear motion. Okay, so K translational, meaning that the degree of freedom, we will only take 3. So it's 3 over 2 nRT or 3 over 2 nKT. Okay, so since the questions give us the value for mole, so we will use the first equation where 3 over 2 n is 2.5, R is 8.31, and the temperature is 10 degrees Celsius. So we need to convert it into Kelvin. So 10 plus 273.15. So we will need to convert it to Kelvin. Therefore, the kinetic or the translational kinetic energy is equals to 8.82 exponent positive 3 joule. Okay, so the answer here is A. Question number 29 is chapter 14. A system absorb. Okay, absorb meaning that Q is positive 2090, and at the same time it does the work of 400 joule. Okay, so does a work meaning that it's actually by the system. So our work done is equals to positive 400 joule. Find the change in the internal energy. So from the first law of thermodynamics, heat is equals to change of the internal energy plus the work done. Therefore, the internal energy is equals to Q minus work done. So Q is positive 2090 minus work done is positive 400. Therefore, we will get the change in the internal energy is equals to 1690 joule. So the answer here is D. Okay, last question is question number 30. An ideal gas has undergone two processes A, B, and BC. 8 kilojoule of heat is supplied to the gas in the process of AB, and in the process of BC, 4 kJ of heat is dissipated from the gas. Okay, so meaning that A to B, Q is equals to positive 8,000 joule because it's supplied, and for B to C is actually negative 4,000 joule because the word of dissipated, meaning that lost. Okay, calculate the internal energy of the process BC. So we only want to find the internal energy of the process BC. Okay, so since B to C is actually isovolumetric. Okay, so isovolumetric meaning that delta V is equals to 0. So since delta V is equals to 0, meaning that the work done also equals to 0. Okay, so Q equals to change of internal energy plus work done. So our delta U is equals to Q because work done is equals to 0. Therefore, delta U is equals to negative 4,000 joule. Okay, so the answer here is B. Okay, so that's all for pre-PSPM questions for set 5. Okay, so good luck and see you on next video. Okay, bye.